Have you ever really thought about how your data stays safe in the cloud? Like, truly safe? Well, today, we're going to crack open the code of something called BSFS. It's a file system built with one single obsessive goal: to create a digital fortress around your information. This thing is a really fascinating piece of engineering. So let's dive in and see how it's done. Okay, so picture a digital apartment building, right? Every tenant has their own private space, but they're all sharing the same foundation. Now, how do you design it so that one person can't peek into their neighbor's apartment? Or even worse, how do you make sure a problem in one unit doesn't bring the whole building down? That is the exact challenge that BSHFS was built to tackle head-on. And this is where BSFS comes in. The name stands for Block Storage File System. Look, it's not trying to be the fanciest or fastest file system out there. Instead, it's all about a no-frills, security-first approach designed to solve that one problem of perfect, unbreakable isolation between users. So, what really makes BSFS special? Well, it's not just about storing files. It's about creating these individual, impenetrable vaults for each and every user's data. And here's why that's so important. This design means that even if a breach happens in one person's vault, it's cryptographically contained. It literally can't spread and compromise the entire system. Now, the way BFSF builds its fortress is really cool. Let's look at the key pillars here. It starts with super strong AES 256 encryption, which, is kind of table stakes these days. But it doesn't stop there. It has that true multi-tenant isolation we just talked about. It also provides fail-safe file updates so your data never gets corrupted in the middle of a save. And two of my favorite points, it gets security through pure randomness. And it has absolutely zero external dependencies. It's a self-contained binary, which just massively shrinks its attack surface. So what's the secret sauce behind all of these features? How does it all actually work in practice? Let's open up the security playbook and see exactly how BSFS pulls this off. Okay, at the very heart of its multi-tenant security is this really clever trick called HKDF. Think of it like a master locksmith. From a single master key, this locksmith can generate a completely unique, unguessable key for every single apartment in our digital building. What this means is, even if one user's key somehow gets compromised, it's mathematically useless for opening any other door. The rest of the system stays perfectly, completely secure. And this is another brilliant layer of defense. BSFS intentionally scatters your data blocks randomly all over the disk. It doesn't write them in a neat, predictable line. Why would it do that? Well, it's to stop attackers who might be watching the disk activity. See, if data is written sequentially, they could guess the size of your file or figure out when sensitive info is being stored. By scattering everything, BSFS makes it incredibly difficult for anyone to find any meaningful patterns. And to stop data from getting corrupted, like if your computer crashes mid-save, BFS uses something called a copy-on-write method. So instead of editing your file directly, it makes a copy of the file's internal map, applies all the changes to that safe copy, and then in a single atomic step, it swaps the old version with the new one. It's like instantly replacing a photo in a frame. This guarantees that even if the power goes out, your original file is still there, perfectly safe and untouched. Okay, so we've seen the security features. Now let's pop the hood and see how it's all put together. It's one thing to have great ideas, but it's another to build an architecture that actually makes them all possible. So how does this all fit together? The whole foundation of the BSFS architecture is what's called the tenant storage file. This is the outer wall of the fortress, a single, secure file that acts as that personal, portable vault for each user. It contains absolutely everything, all their data, all their metadata. But it doesn't just stop there. Inside this main vault, the space is broken down even further into partitions. You can think of these as separate, locked rooms inside the vault, which creates this awesome layered defense and a really organized, compartmentalized storage system. And inside each of these partitions, these locked rooms, there are two key components. Over on the left, you've got the encrypted block allocation table, or BAT. This is basically the secret index for your files. It knows exactly where every single piece of your data lives. And then on the right, you have the raw data blocks themselves, which is where your actual content is stored, all secure and scattered randomly. Of course, BFS's is a living project, and it has a really bright future. So it's important to see where it is today and, maybe more excitingly, where it's headed. Let's take a look at the roadmap. Now look, BSFS is still in its early stages.
but it provides a rock-solid foundation for everything that's coming. The current version has some pretty clear limitations, like it only supports a single partition and there's a cap on files. But it's really important to see these not as weaknesses, but as the starting point from which all the future awesome features are going to be built.
And the future for BFS is incredibly promising. The roadmap has high-priority stuff like multi-partition support and a Python wrapper to make it easier for more developers to use. But what gets me really excited are the future ideas, like fuse integration. Can you imagine being able to mount a BFS volume on your computer and just use it like a normal disk drive, but with all of this incredible security built right in? So as we've seen, BSFS is a really powerful tool designed for a world that is, and rightly so, getting more and more obsessed with data security. And it kind of leaves us with a critical question. Is this intense security-first level of design going to stay a niche thing for special cases, or is this the beginning of a whole new standard for how we protect our most valuable digital stuff?